Okay guys, so I usually bring home my notes when I do these videos, or I just have made the notes since I have them, and I left them at school today. So for my definition from the book, I'm literally going to write it from the book. So I might be a little slow. Okay, so, because now I don't have all of these definitions just memorized. What we're going to do is we are going to let L. Ooh, that is not what I want. Hold on, back up. Rewind. There we go. We're going to let L be a real number. When that happens, two things happen. The first thing is that the statement the limit as x approaches infinity of f of x equals L means that for each, this is an epsilon, so it's not a normal E, it's a Greek letter, epsilon greater than 0, there exists an m greater than 0. S dot T dot means such that the absolute value of f of x minus L is less than epsilon whenever x is greater than m. Likewise, the statement the limit as x approaches infinity of f of x equals L means that, oops, back up, pause, rewind. Need a negative sign in here. I'm going to approach negative infinity. My bad. Okay, so for each epsilon greater than 0, there exists an n less than 0 such that the absolute value of f of x minus L is less than epsilon whenever x is less than n. So essentially what that's saying is when I take the limits as we go infinity, so positive infinity, it'll eventually, some x value will be larger than it. And then when I go on the opposite way, same idea, there's an x value that will be bigger than that. So, sorry, my knees bother me. I'm really trying to get comfortable here. When we first talked about limits, we talked about limits at specific values. And what we did when we got to this part is we could just plug them in. So essentially what I'm going to do is just plug in infinity. So I have the limit as x approaches infinity of 5 minus the limit as x approaches infinity of 2 over x squared. Now this first part's asking me to find the limit of a constant. Well, since nothing's changing, there's nothing really to plug infinity into. So when that happens, I'm always going to be approaching 5 forever and ever and ever without end. So my answer here for that first part is 5. And then when you plug in infinity down here in the bottom, It's like saying 2 over really, really, really big number. So say 200,000, for example. If you actually plug that into a calculator, you get a really small decimal. If I did it on my calculator, it'd give you something 10 to the negative something. So when the bigger values we pick for this, because we know infinity is not an exact number, it's something we can only grasp at. We're grasping at straws type of thing. We don't really know what it is. But we know that we're getting infinitely closer to 0 when we plug it in there. So it's like saying 5 minus 0. So the limit here is just 5. Next one. Same kind of idea, taking the limit of each piece. So the limit of a constant is still going to be that constant, so 7. Again, plugging this in here is going to make it go to 0. And again, plugging it in here is going to make it go to 0. So my answer is just a good old 7. Now, when I'm given something that has a fraction, let's try it. Well, if I put infinity in there on top, I'm going to get infinity. And if I put infinity on the bottom, I'm going to get infinity. And infinity over infinity is not equal to 1. Because it's not a specific answer, we cannot say specifically as 1. We know 3 over 3 is 1. We have 3 on top. We're evenly divided it by 3. So therefore, each person gets 1. Well, since infinity is not an actual concrete number, we can't say that infinity divided by infinity is 1. It doesn't exist. It's like saying infinity times infinity. It doesn't happen. It's not real. I mean, it's real, but it's not something concrete. It's so large that you can't possibly even do it. So what we have to do instead is we have to divide out pieces so that we can try and throw that infinity in there. So when we do is we divide by the biggest x on the denominator. And what I mean by biggest x is I mean the biggest exponent of my x. So in this case, I just have x to the first. So everything's just going to be divided by x to the first, or essentially x. So I have the limit as x approaches infinity of 2x minus 1 over x over x plus 1 over x. And remember, we're doing this so we can try and simplify stuff down. Still have not taken that limit, so I need to keep writing it there. The x's with the 2 cancel, so I'm left with 2. I don't have anything cancel else on top, so it's 2 minus 1 over x over 1 plus 1 over x. Now I have this simplified down. Let's see what happens when we start plugging in my infinity. Well, again, when I take the limit of a constant, it's just going to be that constant. When I plug it in here, it's just going to be 0. On the bottom, again, it's a constant, so 1. And then again, a fraction, excuse me, so that's going to be 0. So it's 2 divided by 1, which is just 2. My toes are cold. Alright, let's try this next one. Now, I said biggest x because we're talking about the biggest exponent with the x. Now, in here, I know we have a 3x, but we're still just going to divide by x. So we have the limit as x approaches infinity of 5x minus 4 over x over 3x plus 1 over x. So let's go ahead and simplify that down. So the limit as x approaches infinity of 5 minus 4 over x over 3 plus 1 over x. We're simplified down, so we can go ahead and throw in the limit on each piece. So as we approach that constant, we're still a constant. As we approach the thing as the fraction, we're 0. Constant, still a constant. Thing as a fraction is 0. So I essentially have 5/3 for this answer. Okay, sometimes we have x squareds. So we do what's biggest on the bottom. So because now we have an x squared on the bottom, we're going to divide everything by an x squared. So we're going to have the limit as x approaches infinity of 2x plus 5 over x squared over 3x squared plus 1 over x squared. Let's simplify down. Now, I'm going to have, not all my x's are going to cancel on the top here. I'm going to be left with 2 over x plus 5 over x squared over 3 plus 1 over x squared. When I go ahead and throw the limit in, or take the limit of each, on top I'm going to end up getting 0 plus 0 over 3 plus 0, which 0 divided by anything is just going to give me a nice, lovely little donut hole. Next one. Again, we have that x squared, so we're going to divide by x squared. So we have the limit as x approaches infinity of 2x squared plus 5 divided by x squared over 3x squared plus 1 divided by x squared. Let's go ahead and reduce it down. So the limit as x approaches infinity of 2 plus 5 over x squared over 3 plus 1 over x squared. Go ahead and take the limit of it. I'm going to get 2 plus 0 over 3 plus 0, which is just 2/3. I think this is my last one. Yep. Okay. Last one. Again, going to only divide by the biggest on the denominator, so we're going to divide by x squared. So we have 2x cubed plus 5 over x squared over 3x squared plus 1 over x squared. So when I simplify that guy down, I'm going to be left with the limit as x approaches infinity of 2x plus 5 over x squared over 3 plus 1 over x squared. When I go to take the limit of this guy, I have an x here. I don't have just a constant. If I throw infinity in there, I'm going to end up with just infinity. And infinity plus or minus or divided by anything is still infinity. And since we're looking for a limit to see if it approaches a specific value, this limit does not exist because you're always approaching infinity. You will never approach a single value. You'll go on and on forever without end. So in this case, the limit does not exist because you're approaching infinity. There's your homework.